Hello students, in today's video we are going to prove rules of Boolean algebra. So as already shown in the tutorial that we have the basic 12 rules in the Boolean algebra. So our rule number 1 is a or 0 will be always equal to the variable a. That means whenever we will or a variable with 0, that will be always equal to the variable. So it means that this rule can be shown using the gates. So suppose we will here first of all make the truth table for the OR gate. The truth table for OR gate for two variables is, say suppose for example we have a and b as two variables. So for two variables we will be having the input as 0 0, 0 1, 1 0 and 1 1. What will be the output? So here we will consider it as x. So 0 0 in OR gate will be equal to 0, because the output of an OR gate will always be high whenever one of the bit in the input will be high. Otherwise it will be low, that means 0. So here also we are having one bit as high, so it will be 1. Here also one bit as high, here a is 1 and b is 0, so the output will be 1. We have a as 1, b as 1, so the output will be 1. That means the output of the OR gate is always high whenever either of the bit will be high. So that means we have the law a or 0 will be always equal to a. We have to prove it. So see, for example we will do it using the gate. That means first of all I will show it using the gate implementation like this. We will consider an OR gate here. It means if I will give the input to the gate as 0 or 0, that will be equivalent to my x will be equivalent to 0 and 0 will be equal to 0. So suppose this is a, I am putting a as 0. 0 or 0 is equal to 0 according to the truth table. That means it is equivalent to the a. So if I am putting this a as 1, that means 1 or 0 is equivalent to, that will be equivalent to 1. 1 or 0 according to the truth table is equivalent to 1. So that means again that will be equivalent to a. That means this rule a or 0 is equal to a is satisfied. Now our second rule is a or 1 is equal to 1. That means whenever you OR a variable with 1, that will be always equal to 1, because as I told you in our OR gate, the output will be high whenever either of the bit will be high. That means if we have one input as 1, it will be always equivalent to 1. You can simply check it from the truth table. Similarly, we have the third rule is a and 0 is equal to 0. The truth table for the AND gate is, I will show it here. Again for the 2 bits, the output of the AND gate will be high always whenever all the inputs will be high. Otherwise, if any of an input is low, then the output will be low. So for example, for 2 bits we will consider, so it will be like this: 0 0 0 1 1 0 1 and 1. For 2 bits we will have only the 4 combinations. So the output x in the AND gate will be 0 and 0 is equal to 0, 0 and 1 is equal to 0, 1 and 0 is equal to 0, because we should have all the inputs as 1, that means high. Here we are having both the inputs as high, so the output will be high. That means when both the inputs will be high, only then the output will be high, otherwise it is low. So if you will see in this rule, the other variable is already set to 0. So that means whatever the variable a will be, it will be always equivalent to 0. If we will take a is equal to 1, that means 1 and 0 will be equivalent to, according to the truth table, 0. And if we will take a as 0, 0 and 0 according to the truth table is equal to 0. So again I will show here as a gate. So for the AND gate we represent it as this. So here we have a and here we have 0 as an input, and the output x will be always equal to 0. So this was rule 3. This was rule 3. Moving towards the rule 4 of the Boolean algebra, we have rule 4 of the Boolean algebra is a and 1 is equivalent to a. That means whatever the input a will be, that will be the output. Again, if you will check the truth table of the AND gate, you can see that if you will give input of a, say suppose I am setting a as 0. So if I will do it as, that means it will be as 0 and 1. That will be always equal to 0 and 1 according to the truth table of AND is always equivalent to 0, because to make it high as a result we need both the inputs at high value. So if we will take a as 1, that means we are setting this a as 1, it will be equal to 1 and 1, that will be equivalent to 1, that is again the a, the output is again the a. So this is rule 4. Now we will take the rule 5. Our rule 5 is equal to a or a is always equivalent to a. Say we will let a is equal to 0. So that means we will or 0 or 0. What is 0 or 0? That is always equivalent to 0 according to the OR truth table. So if I will let a as 1, 1 or 1, that is equal to 1. This means that again the output is equal to the a. So this is the rule 5th. Similarly, now we will see the rule number 6th. Rule number 6 is a or a complement is equal to 1. That means, for example, I will let a is equal to 0. That means its a complement will be equal to 1. A complement is actually the NOT gate. We represent it by the NOT gate. What is the function of a NOT gate? It simply converts a bit. For example, we have the value as 1, it will as 0, it will give the output as 1. It takes only one input and gives one output. If we have taken an input as 1, it will be equivalent to 0. I have just assumed the value of a here as 0, so that means the a complement will be equivalent to 1. So let's put it in this rule and we will see what will happen. That means a is 0 plus a complement is 1. That means 0 or 1 according to the truth table of OR. A or 1 is always equal to 1, which is true, which is the rule. Now let's see what will happen if we will let a is equal to 1. If a is equal to 1, a naught or a complement will be equivalent to 0. Again we will put it in the formula, or I will say the rule. So it will be 1, a is 1, a complement is 0. That is again equal to 1. Because in the OR truth table we say that either of the bits should be high, then the output will be high. That means if any of the input is high, the output will be high. Okay. So now we will take the rule number 7. Our rule number 7 is a and a is equal to a. So this will be always equal. A and a will be always equal to the a. Suppose you are taking a as 1. A and 1 and 1 will be always equal to 1. If you will let a as 0, 0 and 0 will be always equal to 0. So that's the rule number 7. Now we will move towards the rule number 8. Rule number 8 is a or a complement, sorry, a and, this is dot here, a and a complement is equal to 0. See, if I will take a, I will let a is equal to 1. Therefore, a complement will be equivalent to 0. So we will put it here. That means a is 1 and a complement is 0. 1 and 0 is always equivalent to 0, because in AND we need both the inputs should be at high, then only the output will be high, otherwise it will be low. Okay, then we will take, similarly it can be solved for, like if we set a, let a is equal to 0. So therefore a complement will be equal to 1. So we will again put it into the rule. That means a is 0 and 1, that will be equal to again 0. Now number 9, rule number 9 is a double complement is always equal to the a. Whatever the variable is, if you double complement it, it will be equal to the variable. How? See, suppose for example, I will do it like this. Say suppose for example, I am taking an input, I will just do it through the gate. This is my NOT gate. I am giving an input as a. So suppose this is the single, this is my a. This is my a and this is my a complement. And then again I am giving it to the another NOT gate. So the output will be a double complement. Now suppose I am putting this a as 0. So the complement of a, the output here will be equivalent to 1, right? That will be the a complement. That means this will be equal to 1. Then again I will complement it, right? 1 complement will be again equivalent to 0, which is the actual a. So that's how we do it. Now we will take the another rule, that is rule number 10. See, rule 10 is a or ab is always equivalent to a. We will prove this rule, we will prove it by applying distributive law, rule 2 and rule 4. So first I will write those rules. What is rule 2? Rule 2 is a or 1 is always equivalent to 1. Our rule 4 is a and 1 is always equivalent to a. So now we will try to solve it. Like for example, I will write this again. We have a plus a b. That will be equivalent to, that should be equivalent to a somehow. Now we will do it like, if you will apply the factoring, like we will just take this a as common. A will be taken as common according to the distributive law, or we will take it as common. So here we will have 1 plus b. So if you will multiply it again, it will be a plus ab. Fine. So now we will apply the rule 2. Our rule 2 is a or 1 is always equal to 1. So here we have b, like this is the variable, it can vary, the name of the variable can vary. So whatever the variable is, if we OR it by 1, it will be always equal to 1. That means this will be equal to 1 according to the rule 2. That means we will be left with a and 1. Now again rule 4. We will apply now rule 4. Our rule 4 is a and 1, that is always equal to a. So we are doing the same thing. We are ANDing a with 1. Therefore a and with 1 will be always equal to 1, which is equivalent to the right hand side, So we have proved that LHS is equivalent to RHS. Therefore the rule is proved. So again, if you will do it using the truth table, suppose for example you want to do it using the truth table, you can just make a truth table and you can prove the laws or these rules using the truth table as well. Like we will take a, b, then we need in the rule a multiplied by b, or I will say a and a plus a, b. Therefore if you will give the input to this, it will be 0 and 0, this will be 0 and 1, this will be 1 and 0, this will be 1 and 1. A and b, we have to do a and b. 0 and 0, 0 and 0 will be equal to 0, 0 and 1 will be equal to 0, 1 and 0 will be equivalent to 0, 1 and 1 will be equivalent to 1. So again a or and, now we have to just or this and this. So 0 or ab will be equivalent to 0, this or this, 0 or 0 is equal to 0, 1 or 0 that is equal to 1, 1 or 1 that is equal to 1. If you will see that these values are equivalent to this, that means we have proved that a plus ab is equivalent to a. So we will prove rule 11 and 12 in our next video. So thank you for watching the video.